In this video, we're going to explore solving multiple step equations. If you review from last time, we remember that solving an equation happens by applying an inverse operation in order to isolate or get the variable alone on one side. So again, an inverse operation is the opposite and it's going to undo a given operation. So if we see addition, we can apply subtraction and vice versa. And if we see multiplication, we can apply division and so on. Last time we only saw one-step equations where there was only one operation we needed to cancel. In this video I'd like to look at if there's more than one operation, which one is it that we need to deal with first, or in other words, does order matter? And the answer is that we apply inverse operations to multiple operations in the opposite order of PEMDAS. So the key thing here is that it's the opposite order. So if you recall from last time, we used to start with parentheses, then exponents, then multiplication and division, then addition and subtraction. But since we're working in the opposite order, we're going to work backwards, or again, the key idea we see down here is that we're actually going to, quote, undo PEMDAS. So we're going to start first by trying to do the opposite of any addition and subtraction we see, then trying to undo any multiplication and division we see, then back to exponents, and then back to any parentheses. So let's see if we can look at a couple of problems in action here. In this first example, we see 3x minus 6 equals 9. I notice that there are two different operations. First we have 3 times x, and then we have a minus 6. So there's multiplication with the 3 and the x. And then there's also subtraction. And if we think of the opposite of the order of operations, the last thing we normally do with order of operations was addition and subtraction. So in this case, the first thing I'm going to deal with is this negative 6, the subtraction. Now, just like before, if we want to, we can drop that line right down the middle of our equal sign, help us to split up this equation. And now I'm going to apply inverse operations to both sides. So since I have subtraction, I'm going to apply addition, or the inverse operation, to both sides. And I notice that this gives me 3x minus 6 plus 6 equals, and then if I add the 9 and the 6, that's 15. Now because negative 6 and plus 6 are inverse operations, those are just going to add to 0, or in other words, we're now left with 3x equal to 15. So, now that we've eliminated our first operation, now we can deal with this second operation, which is the multiplication. And since the inverse of multiplication is division, I'm going to apply that division to both sides. So I'm going to divide by 3 on the left, and I'm going to divide by 3 on the right, leaving me with x equals 5. Now whenever we solve, we always want to check by plugging this back in. So I'm going to go back over this side. Starting with my original equation, 3x minus 6 equals 9, I'm going to check to see if 5 is correct by putting that in for x. And I know it's always good to put parentheses around that to make sure we're following the order of operations. Now we're not solving anymore, we are simplifying, so now I'm going to follow the order of operations in the normal way. So I am going to multiply first. My 3 times 5 would be 15 minus 6 equals 9, and I can conclude that 15 minus 6 is 9, giving me 9 equals 9, which confirms that this is correct. So again, big difference here is that when we're solving for x, so when we solve over here, this is where we're doing the opposite of the order of operations. So as a reminder, we started with the inverse of subtraction, since that's the last thing in the order of operations. Then we did the inverse of multiplication. But when we're actually simplifying and checking our work, we follow the order of operations, starting with the multiplication and then doing the subtraction. Here's the second problem, and again I want to look at the different operations we have. First, I have x in a fraction bar 5, that means that's division, and then I have plus 3, so there's our addition. Now I want to undo PEMDAS, or undo the order of our operations when we solve. So I want to start with the last thing we normally do, which is addition, and I need to do the inverse of this operation. So I'm going to go ahead and drop our line down the middle again. And again, inverse of the order of operations, I recognize that addition is normally the last thing we do. So that's the first thing I'm going to cancel from both sides. I'm going to subtract 3. And that gives me x over 5 plus 3, and now minus 3, equals 7 minus 3. Now I'm happy to see that plus 3 and minus 3 just add to 0, so I'm only left on this side with x divided by 5, and then 7 minus 3 is 4. And now at this time we're in pretty good shape. The only operation I have left is this division bar, and I know that that division bar is the inverse of multiplication, so I can apply multiplication by 5 to both sides of my equation. And again, just to make that a little bit more clear, I can even make that in a different color so it pops. I'm applying that times 5 to both sides. And since division and multiplication are inverse operations, I'm only left with x on this side equal to 20. And just as a reminder, we don't necessarily have to write this out, but those 5's go away because 5 divided by 5 is just 1, and I don't need to write 1 times x, which is why we can just simply write x equals 20. So again, I want to check this operation. I'm going to start with my original equation. X over 5 plus 3 is equal to 7. And I'm going to plug in that 20. So 20 over 5 plus 3 equals 7. And again, now that I'm simplifying, I want to start by following the order of operations. So I'm going to do division first. And that's going to give me 4 plus 3 equals 7. And we see that that is true, that 4 plus 3 is 7. So we can verify that our answer is correct. Next example, we're getting a little bit trickier. I want to again zero in on the different order of operations I see here. I notice that the 2/3 and the x, there's nothing between those, so I'm assuming again that that's multiplication. Over here, I do see subtraction by 11 over 4, and since we're trying to solve for x, I need to do the opposite of the order of operations. So the first thing that I'm going to do is the inverse of that subtraction. That's the last thing in the order of operation. It's the first thing we're going to cancel. So I'm going to add 11 over 4 to both sides. Okay, now this is going to give me 2/3 x minus 11 over 4 plus 11 over 4. And on this side I still have 5, and now that plus 11 over 4. So now I recognize on the right hand side, negative 11/4 and 11/4 add to 0. So I'm just left with that 2/3 x here. Now to add the 5 and the 11/4, I need a common denominator. We've been pretty good at this so far, but I'll write it out anyway just to be careful. That 5 can turn into, remembering that's a 5 over 1, I need to make the denominator 4. So if I multiply both the top and the bottom of this by 4, then I'd end up with down here 20 over 4, and I'll keep that back in black, 20 over 4 plus 11 over 4, which if I combine those, I get 2/3 x equals 31 over 4. Okay, so that's all just our first operation. Again, I started by canceling subtraction because that's the last thing in the order of operations normally. Okay, so let's come over onto this side, and we'll use a little bit of our check space to finish this problem up. I still need to isolate the x, and I notice that the x is connected by this 2/3. Now this is again where it gets tricky. Since it's multiplication, I'm going to cancel the multiplication with division. But if we remember, dividing by 2/3 is the same as multiplying by its reciprocal. So really what we're doing is multiplying both sides by the reciprocal of 2/3. If you remember this from our work with fractions, I'm really doing, again, multiplication by the reciprocal. So that's where this 3 over 2 came from on both sides. I'm recognizing that I need to divide by 2/3, but instead of dividing by a fraction, I'm multiplying by the reciprocal, which is the 3 over the 2. Good. So multiplying this gives me 6 over 6x on the left side, and then on the right, that looks like 93 over 8. And since 6 over 6 is just 1, I don't actually need that, and I see that we end up with just x equals 93 over 8 for our answer. So here's our solution. Now we want to check this solution, so I'm going to plug this back in to our equation. So I'm going to say 2/3, and I'll put a little line here so we know this is where our check begins. I'm going to put 2/3 times, instead of x, I'm going to put in that 93 over 8 minus 11 over 4 equals 5. And we're going to do quite a bit of work in this next step here. First, I can multiply our first two fractions. That looks to me like 186 over 24. Now I automatically know I want the denominator to be 24, so I'm going to multiply the top and the bottom of this fraction by 6. That's going to give me that 24, or in other words, minus 66 over 24 equals, and again, if I imagine that this 5 is over 1, I need to multiply both the top and the bottom by 24. So 24 on the top and also 24 on the bottom, which would give me 120 over 24. And we can actually check this. 186 minus 66 is exactly 120 over 24. So I can confirm that yes. A little bit of a messy answer. And I don't even really need to simplify. I can just see that yes, those are equivalent. So we must have found the correct solution. Last example I want to do with you on this video, I noticed there's something a little bit different, and this is a little tricky. I noticed that there are two operations, our division bar, which we normally would do after we dealt with the subtraction on the top, but the difference here is that the division is not only just subtracting away from the x, but it's also dividing away from the 4. And when we had a whole fraction bar, I mentioned this in an earlier lesson, we actually have to assume that there are an implied set of parentheses on the top. And because parentheses are normally the first thing we do by order of operations, it's actually going to be the very last thing we do when we solve for x is deal with that negative 4 on the top. So again, that implied set of parentheses on the top around the x minus 4 means that the first thing we actually want to do to this equation is deal with the division, which means that I'm actually going to multiply both sides of the equation by 5. I'm going to deal with that division, and the division I see in this fraction bar, by multiplying both sides. Good. So when I multiply, I can actually see here, if I write it out, the 5 and the 5 are going to cancel, or in other words, I'm going to end up with 5 over 5 times x minus 4 over 1, and I really don't need to write 5 over 5 because that's just division, multiplication by 1, and that's unnecessary. Now over here, again, if I assume that that 5 is over 1 on both sides, I'm going to end up with 5 times 14, or in other words 70 over 10, and this is nice because we can actually just reduce that down to 7. So really what I have here is x minus 4 equals 7. And now that we've dealt with that division, I can deal with the addition. So this is going to be pretty simple. Again, I can put that line down the middle. Should have done that a little bit earlier, but never hurts to throw it in. I can now do the inverse of subtraction by adding 4 to both sides, leaving me with just x equals 11. And as a quick check, if we put that in over here, if I take my original equation, x minus 4 over 5 equals 14 over 10. If I plug in that 11 into the x, I notice that 11 minus 4 is 7/5, which works out well because if I divide 14 and 10 by 2, so if I divide the top by 2 and if I divide the bottom by 2, and notice we're really just dividing by 2 over 2, which is 1, I see that this does simplify down to 7/5, and that this is in fact equivalent. Okay, so for the rest of the night, what I'd like you to do is look at the 4 on your own problems, and the next class we'll check in on those 4 problems and also on these problems from the video.